Hi, in this video, I will explain what is the curvature, what is the radius of curvature, and how to find the radius of curvature in Cartesian and polar forms, and what are the applications of polar curves that we will see in this in this video. So first, the curvature is defined as the rate of change of the direction of a curve with respect to the distance along the curve. That is, radius curvature is denoted by k, and it is given by d theta. That is change in the direction, change in the angle with respect to the change in the arc length. Then radius of curvature is defined as the reciprocal of the curvature. Whatever the curvature is there, so its reciprocal will be taken as the radius of curvature. That is, radius of curvature is denoted as rho, that is equals to 1 by k, which implies rho is equals to ds by d theta. S is used to denote the arc length, that is bended curve length, and theta is the change in the angle. So that is change the rate of change of arc length with respect to the angle theta is known as the radius of curvature. So radius of curvature at a point on a curve is the radius of the circle which fits the curve at that point. Now we'll see how the how to understand this radius of curvature. See, there is a blue line with the curve and we have a circle. See, at this this black dot, you can see this a portion of the circle and a portion of the curve are same. So, which means, so when this type of situation arises, a portion of the circle and a portion of the curve coincides, then the radius of curvature of the curve at this point is same as the radius of curvature of the this curve. The radius of curvature of the curve and the radius of this circle will be same. So next, radius of curvature in the Cartesian form. So let us take the curve y equals f of x, the Cartesian curve, and the formula is given by rho equals 1 plus y1 square to the power of 3 by 2 by y2. So this y1 and y2 are y1 dy by dx, that is first derivative of y, and y2 the second derivative of y. Now we will see what is the procedure, how to find the radius of curvature in case of a Cartesian curve. That is, let us take the curve y is equals to f of x and then find out, differentiate the given curve to find y1 and y2, that is dy by dx and d square y by dx square. Then you substitute these two y1 and y2 in the formula and simplify to get the required result. This is how, means we have to find y1 and y2, and then substituting in this formula will give us the that is radius of curvature of the given curve. Now, what is the radius of curvature in the polar form? Let r is equals to f of theta be the given curve. And the formula rho equals r square plus r1 square to the power of 3 by 2 divided by r square plus 2r1 square minus r into r2 is the formula. So then find out r1 and r2. r1 means dr by d theta, r2 d square r by d theta square. Now what is the procedure? Again take the r is equals to f of theta, find out the r1 and r2, differentiate with respect to theta, and then substitute these r1 and r2 in the formula, that is rho equals r square plus r1 square to the power of 3 by 2 divided by r square plus 2r1 square minus r into r2. Means in case of a polar form, we have to find out r1 and r2, we have to substitute in this formula, and we have to simplify to get the uh, that is the radius of curvature. Now we'll move on to the application part. So what is the use of the application part? See, the radius of curvature is helpful in minimizing the construction cost and the operating cost of a super elevation. So in order to construct the stadium like this, we have to use we will use this radius of curvature in order to decide the amount of bending of the stadium. And then moving on to the applications. See, the radius of curvature is also helpful in designing the railway tracks, trams, and monorails. That is use because in order for the safe travel of the railways, that is the what is the bending, how much the track can be bended. So that concept can be decided by using the radius of curvature. So that same thing, same amount of bending can also be used in finding the bending amount of bending in case of the trams as well as in the monorails. Means unless you decide the amount of bending, it is difficult for the either the train or a tram or a monorail, because with the high speed, that if the bending is more, the train with the high speed won't stay on the track. So what is we may the so it is not possible for the train to stay on the track itself. So by using the concept of the radius of curvature, we can decide the amount of bending. So continuing on that, so even the amount of bending is also used in case of the road construction also. So that the car or a bus or any other thing in a curve, what speed it can maintain, so that it can go through the it can cross the that curve. So in order to have a what is that a safe travel of the vehicle, the road is constructed like this, that is it is called the elevation. So instead of a flat road, some elevated road will be constructed so that the vehicle will move through the curve. So radius of curvature is also used in civil engineering, that is bending of the beams, and optics means how to form the convex or a concave lenses, and the printed electronics. Like these type of beams also, how much it can bend. So what is the effect of the bending can also be decided by using the radius of curvature. In case of the optics, what is the focus? You can see this focus, it all depends upon the bending. So in order to get the clear focus, what should be the shape of this, it all depends upon the radius of curvature. Even in the printed electronics also, the concept of the radius of curvature will be used. Thank you.